Hello, Calc students. Today we will be going over L'Hopital's rule. This is what happens. Let's say when you have a function where it says you have to try to find the limit as x approaches c of f of x over g of x, and that results in something called the indeterminate form, or 0 over 0, or it could result also in infinity over infinity, and that's not one because infinity is not a number; it's a concept. Just so that you know. Instead, to find that you take the derivatives of both the numerator and the denominator and keep doing that until you get a set answer. Let's see how this works in action. Let's see you have the limit as x approaches 0 of sine x over x. Now, the first step to any problem like this is first try plugging in, obviously, right? So you get sine of 0. What's sine of 0? Sine of 0 is just 0. So you get 0 over 0. This is an indeterminate form. So this is cannot be solved this way. So instead, it's equal to the derivative of sine x is cosine x. The derivative of x is just 1. And then when you plug in 0 for x, you get cosine 0 over 1. What is cosine 0? Cosine 0 is just equal to 1. And 1 over 1 is just equals to 1. So that's how this essentially works. Let's try another one. And you can pause the video and try this one on your own after I write down the problem. So it's the limit as x approaches 0 of 1 minus cosine x over x squared. Feel free to pause and try that on your own. Okay, so you want to begin by plugging in as always. You get 1 minus cosine 0, which is 1, over 0 squared, which is 0. So you get 0 over 0 again. And that's an indeterminate form. So you have to solve it using L'Hopital's rule. And the derivative of 1 is just 0. The derivative of negative cosine x, or cosine x, would just be negative sine x. But since it's multiplied by a negative, it would just be plus sine x over the derivative of x squared is just 2x. So you get this. And then once you plug in, you can see that it results in 0 over 0 again. So you have to do this again, once more time. So the derivative of sine x is just cosine x over 2x. The derivative would just be 2. Cosine 0 is 1. See, right? 1 here. So it's equal to 1 over 2. So that's what this derivative is equal to. Moving on. Here's another one. But this time, this is one with infinity. You can try this one on your own, but let's write it down. So the limit as x approaches infinity of e to the x over x squared. You have to try to find the limit. You can feel free to pause the video now and try it out on your own. All right, so let's begin. So you start by plugging it in. So you get e to the infinity over infinity squared. Well, infinity squared is just infinity, and e to the infinity, since it's a constant to the infinity, is just infinity over infinity. And that's one of the forms that we have to use L'Hopital's form for, as you can see here. So you have to redo the limit, and you take the limit of the derivatives. So it would be the limit as x approaches infinity of e to the x, because the derivative of e to the x is just e to the x, over 2x, because the derivative of x squared is 2x. Now, when you plug in again, you would get infinity, because e to the infinity is just infinity, and over 2 times infinity, which is just infinity. This is in the same form, so you have to do it again. So the limit as x approaches infinity of the derivative of e to the x, which is e to the x, over 2 is equal to infinity over 2. And infinity over any constant is just equal to infinity. So that is the answer for that one. Okay, let's try another a little bit more complicated one. Let's try the limit as x approaches 0 of, let's try the ln of x plus 1. Ln of x plus 1 over x. All right, when you plug in, you get the ln of 1 over 0. The ln of 1 is just equal to 0 because e to the 0 equals 1. So it'd be 0 over 0. And this is where we have to use L'Hopital's rule again. And now we have to just take the derivative. So it'd be 1 over x plus 1 since that's the derivative of ln of x plus 1 times 1 because of chain rule over 1. And that's just equal to 1 over x plus 1, which is just equal to 1 over 1, which is equal to 1. So that's the answer for that limit. Now let's try one more, a little bit weirder one, but let's try it. This is going to be the last example. You can feel free to pause and try this out on your own. It'd be x as x approaches infinity. The limit as x approaches infinity of 3x squared plus 5 over x cubed plus 2. Now you can plug in and you'd get infinity over infinity, obviously, because infinity squared is infinity. 3 times infinity is infinity, plus 5 is also infinity. Infinity cubed is infinity, plus 2 is still infinity. So here we have to use L'Hopital's rule again. So you would get the limit as x approaches infinity of the derivative of 3x squared is 6x, plus the derivative of 5 is just 0, over 3x squared, because since that's the derivative of x cubed, plus the derivative of 2, which is just 0. And you'd get 6x over 3x squared. When you plug in, you still get infinity over infinity, so you have to do this once more. So the limit as x approaches infinity of 6 over 6x. And now you would get, when you plug in, you get 6 over infinity. And what is 6 over infinity equal? Any constant over infinity is always 0, since infinity is infinitely times bigger. So that's it for this video, and as always, please remember to like, comment, and subscribe for more calculus-related content, and also physics, as I'm working on that too. Thank you.